Now let's talk about equivalent or equal fractions. Equivalent fractions are rational numbers that represent the exact same quantity on a number line. For example, I've got on the screen 3 different versions of the exact same quantity. Now, on the left, we can easily see that there are 3 pieces that make the whole, so I know that the denominator will be 3, and 2 of them are selected. In the center, I can see that I have 6 pieces to make a whole, so the denominator is 6, and 4 of those are shaded in. And then on the right, I can see that I have 1, 2, 3, 4, 5, 6, 7, 8, 9 pieces to make a whole, so the denominator is 9, and I have 6 of those shaded in. But if we kind of blur our eyes a bit, we can see that each of these diagrams is exactly the same length, and the shading stops in the exact same place. So even though each one has a different number of equal-sized pieces, overall the collective shaded pieces represent the same quantity. So the fraction 2/3 is equal to 4/6 and is also equal to 6/9. The fundamental law of fractions helps to clarify this. It says that if you have a fraction a over b, and n is some non-zero number, then we can multiply up our fraction as long as we multiply on top and bottom. So if I started with the fraction 2/3, and I multiply the numerator by 3 and the denominator by 3, I will get 6/9. So I started with 2/3, I multiplied by 3/3, and I get the exact same value, 6/9. Another way to explain why this works is if we look at 3/3, it's actually equal to 1. 3 divided by 3 is equal to 1. So you could look at this as if we said 2/3 times 1. Of course that's equal to 2/3. What we're saying here is that although these two fractions look different, they represent the same quantity at the end of the day. Let's practice finding an equivalent fraction. Maybe we're looking at the fraction 12/42. Now we don't want to draw that. 42 little tiny squares would be a lot to draw, so we're going to visualize that in our mind. I want to find an equivalent fraction representing the same quantity, but this fraction that I want needs to have a denominator of 210. So the way that we're going to look at this is we're going to say, I know that I can multiply the fraction 12/42 by the same number on top and bottom, and I want to pick a number so that when I multiply it, the bottom comes out to 210. So we need to think of a number that we can multiply to 42 to get 210. So 42 times some mystery number needs to give us 210. And we've done a lot of practice with division, so we know that we can rewrite this as division instead of the missing factor. We can write our mystery number must be equal to 210 divided by 42. And we can do the division here to figure out what the mystery number has to be. Popping that into my calculator real quick, I was able to find that the mystery number is 5. We can check that. Is it true? 42 times 5 does in fact give us 210, so we found the correct mystery number, and that's the number we want to multiply top and bottom to our fraction 12/42 to find the equivalent, a fraction with the denominator 210. So we just need to multiply 12 times 5 to find out what the denominator needs to be, and we find it's 60. So the fraction 12/42 is equivalent to the fraction 60/210, the same way that 2/3 was equivalent to 6/9. The same idea can help us simplify fractions. That fundamental law of fractions basically says we can start with any fraction we want And if the numerator and denominator have some common divisor, we can divide the numerator by that divisor, divide the denominator by that divisor, and we can find an equivalent fraction that is a more simplified version. For example, if we look at 12 over 18, we can see that we have a common denominator. This should not say, oh, sorry, I'm reading that wrong. The numerator and denominator have a common divisor of 3. So we have a common factor of 3 from the numbers 12 and 18. And visually, we can say that we'll take our shaded portions and group them into 3. So I'm going to take 3 shaded portions and draw a green square around them. And I'm going to do that for all of the shaded pieces we have. Because 12 can be divided by 3, I know that I can group these shaded portions into groups of 3 and have a perfect grouping. And the same with 18. I'm going to take 18 and I'm going to group those into 3 using the blue. Now there's 18 total partitions here, so I'm going across the entire fraction bar. Now we're going to go even past the shaded portions. And again, because 12 and 18 are both divisible by 3, those groupings worked out perfectly. And now we can just look at the new groupings that we have. If we look at the blue squares, there are 1, 2, 3, 4, 5, 6 blue squares needed to make a whole, so our denominator would be 6. And then the shaded portions, if we look at the green portions, there's 1, 2, 3, 4. And we can show that algebraically by dividing the numerator by 3 to get 4, dividing the denominator by 3 to get 6. So we can simplify our fraction simply by dividing off any common divisors. And we can do that until we get down to the simplest form, which is where you have divided off the greatest common factor from both the numerator and the denominator. So if we look at the fraction 12 over 18, remember that the greatest common factor between 12 and 18 is 6. Now, in that last situation, we did a common divisor of 3. The greatest common divisor is bigger than 3, it's 6. So if we were to divide 12 by 6, we would have a numerator of 2. And if we had divided 18 by 6, we would have a denominator of 3. And we can show that grouping, just like I did with the divisor of 3. I can show that grouping by making a group of 6 of the shaded portions in green to see that I can make 2 of those. And then I would use the blue to make 6 of the groupings until I finish the entire whole. And we're going to see that there will be 3 of those. So simplifying fractions is just dividing off any common divisors. The simplest form of any fraction is where you've divided off the greatest common factor between your numerator and your denominator. Let's practice doing some simplest form problems. So in our first fraction, notice there are some letters here, but those letters are just placeholders for regular numbers. So we're going to treat them as if they were identical numbers, like maybe A was 3 and B was 5. But we are going to leave them as letters so that we can do this algebraically. First, let's look at the greatest common factor between 28 and 42. We have a number of different ways to find the greatest common factor between 28 and 42. We can prime factor, we can use our calculators. However you want to do it, you'll find that the greatest common factor is 14. So for the coefficient part, the actual number part, we know that we need to do 28 divided by 14 for our numerator to be simplified. We get 2. In the denominator, we need to do 42 divided by 14 to get 3. So we already know that 28 and 42 are going to drop down to 2 and 3, respectively. And then we need to look at the factors of a and b. Now, if we have a times b squared, that's the same thing as a times b times b. And then if we have a squared, that's like a times a, and then b squared, that's b times b. Now, anything that matches, any of these factors that match on top and bottom, we'll divide them off. So I have a pair of a's that match, they'll divide off, and we have 2 pairs of b's that match. The only thing left is a factor of a in the denominator. So for our simplified fraction, we will write 2 in the numerator and then 3a in the denominator. Let's take a look at another one. We have a plus b squared over 3 times a plus 3 times b. Now there's a few ways that you can go about this, and maybe your first thought is to FOIL out your numerator. But I'll tell you, if you can possibly factor your denominator first, you might be in luck. So let's look at our denominator and see if there is a common factor between those two terms. In fact, I see the factor 3. So in the denominator, we could write 3 times a plus b. And if we write our fraction with our denominator factored in this way, we'll be able to see that there is a matching factor on top and bottom. In fact, instead of writing a plus b quantity squared, let's write that out as a plus b times a plus b, so that we can see that there's a matching factor in the numerator and the denominator that we can divide off. And then we're left with a plus b on top and just 3 on bottom. And notice that when we're looking for simplest form, we're taking something that might be quite complex and we're finding an equivalent or an equal expression that will give us the same value. And if you had to choose between working with any one of these top rational numbers or these simplified versions, I bet you would want to use the simplified version. Let's keep going. Our next one, we have x squared plus x over x plus 1. Again, if you can factor the numerator or the denominator, then you absolutely should. I can see in the numerator there's a common factor of x, so I'll factor that off, leaving behind x times x plus 1. And then the denominator is just x plus 1, and we can see that the factor x plus 1 in the numerator divides with the denominator. And the only thing we have left is x. Now, I want to show you something that's an easy mistake to make, and I'm going to write it in blue so that we know that this is a mistake. X squared plus x over x plus 1. You do have a common x in the denominator and the numerator, but we cannot divide those off to say x squared over 1. You can only divide things off that are factors. Remember, we have to multiply to get the matching thing. We can't add to it. So that's what's happening here. We have x squared plus x. Now, if it were x squared times x, and you just had x on the bottom, then you could divide those off. That's fine. But also notice we have x plus 1 in the denominator, and you can't divide that off because this x in the denominator is not a factor. It's a term being added to 1. So the only time that we can divide off common things in the top and the bottom is if multiplication is happening between them. And notice that's exactly what we've had in each one of the cases where we divided off matching numerators and denominators. Let's keep going here. Looking at our next one, we have 3 plus x squared over 3x squared. Now in this case, I don't see a common factor in my numerator. Between 3 and x squared, there is no common factor, and our denominator is already factored completely. Nothing matches between top and bottom, this is actually already simplified. There are no common factors between the numerator and denominator, so we can't make that any more simple than it is. Our next rational number looks very similar. You'll notice the only difference is that there's a coefficient of 3 on the x squared. In this case, our numerator can be factored. Whoops. If I factor off a 3, that leaves behind 1 plus x squared on top. And then on bottom we have 3 times x squared. And because we have multiplication between the 3 and what's in the parentheses, and the 3 and the x squared, we can divide off the 3's, leaving behind 1 plus x squared over x squared. And then that would be our simplest form. Moving on to our next one, maybe you remember a factoring pattern from a previous math class called a difference of squares. A squared minus b squared. That's a number squared minus some different number squared. We call that a difference of squares, and that will factor as a minus b, a plus b, and if you're not quite confident in that, go ahead and FOIL that out, and you'll see that you end up with a squared minus b squared. So if I factor the numerator, then I can see that there's a common factor in our denominator. The a minus b is one complete factor, and actually, if we wanted to, we could imagine that it was a minus b times 1. That way we see the multiplication, and we see the multiplication here. We divide off the common factors. We're left with a plus b over 1. But when we're talking about a rational number and the only thing in the denominator is 1, we leave that off so that it's less complicated. We have one last rational number to simplify here, a squared plus b squared. Now, unfortunately, this does not have a factoring pattern. A squared plus b squared doesn't factor. So this is also completely simplified. The numerator does not factor, which means there's no common factor between the numerator and the denominator.